Hi everyone! Welcome to Pandas for Productivity, the show where I bring a business person's spin to data analysis. In analytics interviews, a very common question is, when did you deal with bad data and what did you do about it? This is something that now that companies are going into the culture of the citizen data scientist, is not just within the scope of the analyst, but that of all of us as well. Every time we explore a new data source, we will have to ask ourselves, what do we expect to see, and how can we validate if that's what we are actually seeing? And if what's actually in the data is not what we expect, we need to know how to deal with it as well. Let's do a quick orientation to this notebook because not all of you would have seen this before. This is a Kaggle kernels notebook, which is an online version of what's quite similar to a Jupyter notebook. Why I work in the Kaggle environment is because they have an integration to Google BigQuery data, and I want to use real data for all of my SQL demos and examples. That allows me to showcase the complexity and the size of real data versus synthetic examples from textbooks. Okay, now we are going to pull the data from the COVID-19 open data source, and we are going to take a look at the data columns. So I've run this cell, and let's take a look at what we have here. We have the date, so that gives us daily data. For the geography, we have three hierarchies. We have the country, subregion 1 and subregion 2, and we can disaggregate each of these country hierarchies by filtering on the aggregation level so that we do not duplicate the numbers. Then we can look at our various kind of patient stats. So we have here the confirmed, deceased, recovered and tested, as well as the hospitalized, intensive care and ventilator patients on a new, cumulative and current basis. Lastly, we have Google's mobility data. So these are the fields here, and they represent whether people are moving around to different types of venues. So now let's walk through the SQL query that we are going to use to test out this data. You will notice that I have taken out all the confirmed, deceased, recovered, tested, hospitalized, intensive care, ventilator, etc. for daily new basis without doing any kind of aggregation. And the reason for this is because I want to test whether my hypothesis is correct. I think that if I'm going to pull just country level data, I'm going to get just daily data for the country, and so I should get 31 rows since I'm pulling this data for the month of October. So these are the key filters in the SQL query. I have the aggregation level. 0 is the highest level of aggregation, so that's the country level without any breakdown into subregions. I've chosen the country to be Hong Kong. There's a reason for this. The country needs to be something that has possibility of having 0 cases on some days. So I can see whether there are going to be 0 cases in the data for the day, or whether it's going to be recorded as a blank or null. Lastly, no surprises here, I have a date filter. I'm filtering the data for the month of October. Okay, let's run this cell. Alright, now we can look at the output. So I just type the data frame name into a cell and run it. And because we only have 31 days of data, we should be able to get all of it to be seen within the notebook. So we are going to look at the number of rows here, and we have, okay, it ends at 30 and the 31st of October, so that we have 31 rows, because in Python, the number of rows always starts at 0. So then we are going to look at where we have missing data, and these 4 columns do not have data for any of the 31 days. So that means that it's very likely that Hong Kong has never reported these stats in the first place. And so if we pull any SQL on this table, we should leave these 4 columns out since they are not going to be meaningful to us. Then we see that for new confirmed, new deceased and new recovered, where we do have valid stats pretty consistently, we still have one day where the 3 of these are missing. Now you'll notice that there are 2 different types of nulls here. You have these 3 which are not a number, and then we have nones in those columns where data has been completely missing all of the time. Don't worry about these, because both of them can be treated the same way in Python, and we can do the same things in SQL in order to fill in or leave out these particular blanks. But just for information, none is the none data type in Python, which denotes a null, and not a number belongs to NumPy, and it also denotes a null. So when we want to get rid of nulls, we have this function called Coalesce in SQL. It takes two arguments. The first is the name of the field that we want to pull, and the second is the value that we want to put in its place if that particular field value for a particular row happens to be a null. We are putting the Coalesce function into practice here in this second SQL query, where I'll show you how we deal with the nulls on the 23rd of October for the new confirmed, new deceased, and new recovered metrics. Okay, going back to our data set, let's look at why we had nulls on the 23rd of October. We do have zero values on a daily basis for some of these metrics. For example, there are many days with 0 for new deceased, and then there are also some days with 0 for new confirmed, but in this case we get 0 instead of null because some of the other metrics are going to have non-zero values and therefore they still need to be reported. Whereas on the 23rd, it is possible that it was a 0 value for all three of the values, therefore there was no report received and it appears as a blank. So based on that theory, we can look at how we want to mitigate this when we pull the data again in SQL. Here I've used Coalesce, but I have put in 0 as the second argument so that new confirmed, new deceased, or new recovered, if any of these are blank, it would be replaced with zeros instead. So let's run this. So again, displaying the data frame here, what we see is that on the 23rd we get zeros, and so we have valid data in all of our rows of data. This is a precursor to the topic that I'll cover next week. I will be talking about how we calculate moving averages in Python and comparing it to how we use SQL window functions. Till then, I hope that this was useful and thank you for watching. See you next time.